So I do a lot of talking. Obviously, this group sort of has an idea of who is Akamai, but I do a lot of presentations in front of other groups, and when I say, who is Akamai, the most common response I get is, who? Most people don't even know who we are. Sometimes I'll get an audience that knows us a little bit better that says we're a content delivery network. The people who have even a better idea of who we are thinks we are the internet, and that is actually a little bit closer to what we are. But really, we're a security company. You may have known us for delivering media. Tom talked about 60 terabits per second. That's a huge number, but it's growing. I mean, right now we're doing about an average of about 43 terabits per second peak every single day. That's the Library of Congress is a measurement I use. That's every 60 seconds we're sending everything that's through the Library of Congress. Where that becomes important is we have a huge amount of data that's going across these networks. We have a huge amount of intelligence that's going across these networks. Nominum is one of our DNS solutions. This is one of the primary places where we look at what are the DNS activities of bots. How can we combat them at the DNS level? We look at Botman Premier, which is another product, and the billions of bots we see on a daily basis. This is where we as a company actually see the future going. Why is it important for somebody like me who is an editor? I see this as basically the proving ground of where you prove that you are actually a security company by taking and using that security information to show other people what is happening. You're not a security company if you're not doing research and you're not publishing it with the world to share that information. Like I said, I'm the editorial director. I'm not quite sure how 20 years of doing security. I was a QSA, a Qualified Security Assessor, for anybody who doesn't know PCI. I have recovered mostly from that time period. I've been with Akamai for 7 years, and basically I took over the SOTI about 2 years ago and have wanted to make what Akamai is doing public for you. For fun, I 3D print. If you follow me on Twitter, you've seen a lot of 3D printing stuff lately. And the other thing I do, somehow didn't make it, well, is play Minecraft for fun. Where that becomes very important for Akamai, do any of you remember Mirai? Yeah. Was on the front lines of our team. Brian Krebs, who was one of the first big attacks that we saw from Mirai, is a friend of mine. We wrote that up and showing how that works, and showing we've been from the very start the target of Mirai, and for some reason every time I say that, my Japanese colleagues laugh at my pronunciation. And don't worry, I won't try any Polish. So what do I mean when I'm talking about credential abuse? It really is simple. It's trying to take a username and password and use it someplace to log into another account. This has been around since the very beginning. Why is it important? We call it credential abuse, credential stuffing, any number of names. Just like every other security company out there, we try and come up with our own individual name for something so that we have, was it SEO, I think is what marketing tells me to say. In our case, credential stuffing is becoming more and more important because we look at it not just because of the amount of it that we see, but because of the cost to companies. We did a Ponemon research study last year where it was showing that about half, a little bit more than half, are anywhere from a little bit under $100 to about $500 per record. And that's not something that most companies can just laugh off. Tom talked earlier about how this was happening to 8,000 accounts a month for one bank. A bank has a lot higher cost than $500 when they have to go through, change the credentials, deal with folks that are having problems. So no matter who you are, this credential stuffing is a problem, and it is costly. And it's only going to get worse because it's going to become more prevalent. Part of what we see is, I do a lot of looking at DDoS data. DDoS was huge in 2016, 2017, into 2018. We saw that Europol did a lot of work with organizations across Europe, the US, across the world to start looking at some of the DDoS places like WebStressor who were selling DDoS. And that's pushed some of the traffic away, some of the profit away from DDoS as a service. This is where we're seeing a lot of traffic go, of the organized crime moving more in this direction. You can actually go online, go to a number of the dark web services. I hate that term, but it really is what it is, and buy huge dictionaries of credentials that have been abused, credentials that have been stolen. Most of these are coming from sites that have already been compromised. As Tom said earlier, we are doing a lot of password reuse. Even somebody like me who's a security professional looking at this data day in and out, I still have some issues where I have some old accounts that I've used the same passwords. Mind you, none of them in my case are financial services, but I do know that there are people out there doing it, and I have had to have discussions with my own wife about that. Luckily, we use 1Password and password vaults, and hopefully you do too. So let's talk a little bit about the evolution. Like I said, this is not a new event. This was actually something that Clifford Stoll wrote up in, I think, 1989, talking about it as something he was seeing in the cuckoo's egg. I started running into it back in 99, 2000, when I was setting up my first SSH server. When I was actually running a home system, I say 30 seconds, and back in 99, maybe it was 30 seconds to 5 minutes between setting a system online and hearing or seeing the first attempts to abuse the logins. Now, I'd actually say you're lucky if it's 10 seconds. There's just so much scanning. It's so ubiquitous. The attempts to log into the servers, the attempts to use those credentials on SSH are just part of the background noise of the internet. That's actually something that I spend a lot of time looking about, is how much of this is just background noise that's so prevalent that law enforcement isn't looking at it. Most of us aren't looking at it because it's just there. You can't do a lot about it in many cases, or you've already done what you think you can, and therefore it's not worth paying too much attention to. It was also a little bit of a problem back in the days of BBS. Quick question, how many of you were old enough that you were actually using a dial-up BBS? Not bad, more than a few of us. I mentioned a minute ago that a lot of these accounts have been coming from previously owned sites. Every time you see a headline about a site being cracked, those credentials are being added to the databases that the bad guys are using. They're selling them. Tom again mentioned that some of these are being verified and then passed on and reused. Earlier this year, there was what was the actual count? I've forgotten the count, but there was a multi-billion account login dictionary that was being shared. It wasn't even being sold. It was just being shared on the public internet. There are several that are bigger that are being sold, but this is all of the different sites that have been compromised over the years are just added to this. So if you've ever been on a site that's been compromised, if you've ever had a password for one of these sites, it's probably here, and there's probably millions others that we haven't seen. Troy Hunt's Have You Been Pwned is actually one of the better sites to go and use, because he also compiles all of these lists of usernames and passwords and making them available so that he can check a hash against what's in those databases against your password and your account. Personally, I'm a little bit scared to go and trust it too much, but people that know better than I do have been telling us for quite a while that it's actually pretty safe to use it. So this is the first of two real-world examples that I want to go into. So this was seen earlier this year. This is, as I said, a financial services company in the US. And this is one of the things that we looked at for the State of the Internet report, which is, here we have a company that's seeing a baseline of account logins and account checkers hit every day. And then all of a sudden, the number of accounts trying to log in erroneously triples. What they see on a regular basis is suddenly a huge difference. At first, they thought they were being DDoS. They thought that the amount of traffic was just a simple attempt to knock them offline and do a denial of service through just a sheer amount of traffic. But what they found out is, looking into it, is actually somebody attempting to log in with all of these passwords. They were using the same passwords again and again. They were using same accounts again and again, interchanging the two. So they were trying to do something that was actually causing a lot of pain. What happened is, then we start looking into the traffic. And as you see up here, 95% of them were the same actual account. I mean, sorry, same actual user agent, happening again and again. In a lot of cases, this isn't too uncommon. This is actually something that, if you're a large enough company, you can actually just make a rule at the edge to deny systems like this. Problem is when you get to this level of traffic, it's too late when it gets to the data center, because it really is a denial of service for you. So you can't necessarily block these at the edge. But this was a dumb attempt. And when I say dumb attempt, I don't mean that the person was stupid. I mean that the bot that was doing this was a dumb bot. It wasn't changing user agent. It wasn't trying to hide itself. It was just going in as fast as possible and trying to get everything. We think that it was a misconfiguration, first of all. We think that actually this may have been the real user agent. We think that it was a set of compromised in systems. It's hard to tell when you're not a company that makes that sort of forensics your first priority when you're dealing with many of these. But from what we'd captured, what we saw, without going back to actually looking at some of the user agents, we think this was real. And in part because of where a lot of the traffic was coming from, Vietnam. The funny thing was, once we did the first steps of correction, this continued for quite a while. This continued for over 3 days, in part because the attacker, maybe they actually didn't even check to see if things were working right. We did see a turn down after about the second day in the amount of traffic, but they just weren't paying attention. They just fired and forgot. We've seen this in other cases where the attacker is coming in and just setting up the tool, moving on, not paying attention to it, and all it takes is one missed keystroke or one missed click of the mouse for the attacker, and it can look like a DDoS to you. These are not uncommon attacks. In this case, what was it? It was 8 million malicious logins over 3 days. Usually that's like a week or two's worth of traffic for them. Domain generation algorithms. So DGA. Do any of you know where domain generation algorithms, what the first botnet that really made a big use of this? It's one of the botnets that we still see as the biggest botnet today, Conficker. Back in 2008, Conficker A and B had one of the first real common setups of DGA, where they would take and create 50, I think in the first set it was 250 domains a day for A and B. With C, they started creating 50,000 domains a day. So what happens with domain generation algorithm is you're taking a pre-shared seed, you're taking the time and date, and this is in general, it's not always this, and you're creating a domain name that is generally nonsense to the human reader, but something that they can say, okay, we're gonna pre-generate this. We're generating 50,000 or 500,000 or 1 million different domain names, but we're only gonna register 1 or 2 a day. You can do that and then buy them with a stolen credit card, and by the time that the domains are catching up with the domains, you've already used it and moved on to the next one. So when Conficker did it, they started doing it because the engineers at Microsoft and other organizations were actually looking at this and buying all of the domains. At 250 domains a day, that was manageable, that was something that they could do. Once it hit 50,000 domains a day, unless you can figure out what the actual algorithm is used to create the domain names, that's not doable. Nobody can afford to buy 50,000 domains a day. Now it's getting even worse. It's down to, sometimes we see some of the domains created in an hour, used for 2 or 3 hours, and then they're never used again. There are times where we'll see them used for an hour or 2 and then maybe used in 6 or 8 weeks again for an hour or 2. This really has become a major problem for the internet because looking at the command and control structure, where you're trying to reach out to it, where the client is trying to reach out to it, is how you have to combat it at the organizational level and make it so that you stop this from happening. There are a number of different algorithms that they're using. Again, this is one of those things where, oops, I'm looking for that button. We had, one of our teams actually wrote up a whole presentation on this particular issue, which I understood but could not recite back to you exactly all of it. And it's worth taking a look at if DGA is something that's interesting to you. So I talked a little bit earlier about how we're actually looking at API-driven traffic rising dramatically. When we looked at this a while ago, you really didn't see back in 2014, 2013, it really wasn't that much of the traffic. APIs were, and computer-to-computer traffic was on the rise, but it was not that prevalent. You look forward to, oops, last year, or about 2 years ago, and actually that API traffic, that computer-to-computer traffic, was about 25% of what we saw. You go back up to today and you start looking at that, and at the HTML level, that's actually getting to be 75% of the traffic that we see. JSON is a huge amount of the traffic that we see on that level. That is literally just computers talking to each other and has nothing to do with human beings. It's when your phone is talking to an application. It's when your laptop is talking to an application. It's computers that are querying each other for information about the weather. Weather is actually one of the single biggest applications that we see on this, and all of the people checking on their phones, checking on their watches to see what's the weather like outside. That's becoming a huge amount of the traffic. The problem here is that, wrong button again, is that this is not necessarily something that people are watching closely from the security aspect. They're not necessarily giving the same technical controls in place to stop API to API abuse as they are with other types of traffic. You are very concerned about if a user account is being compromised. Do you have the same concern for when an API is compromised? The amount of control an API has is pretty big in a lot of cases, and not necessarily given the same thought that user access is. That means that in a lot of cases, the attacker can try more times to get into an API account than they can a user account. Also, there are a lot of other problems with APIs, especially around password use and password rotation. There are some things to do that people are doing to make that password rotation easier, but we're still a little bit ways off. So here's another real-world example, and this one actually to me is a little bit scarier. So what happened was, this is an organization, again a financial services organization, that was having a moderate problem with credential abuse. It was happening regularly. I mean, again, 800 logins an hour of credential abuse was their standard traffic, and all of a sudden it leaped up to 8,700. Okay, that was a cause for concern. They started looking at the traffic, they started talking to our engineers started talking to them, start looking at it, and what they saw was, first of all, a botnet that did 94,000 login attempts an hour, as opposed to what they had been doing of something like 4,800 login attempts total. That one actually was, again, kind of a dumb botnet. It did not have a great range of user agents. It did not have a great range of how they were changing traffic. So they were actually fairly easy to combat. You make a few changes, you start looking at what they do. That one was not too bad. But this highlights what we see in a lot of cases, which is there was a second botnet beneath it. So they were not going as fast. They were not having the same user agent and strings every single time. They were a little bit smarter botnet. So that takes a bit more of intelligence. That takes actually understanding what some of the IPs that botnets are using, where they've hit other people, where they've hit other services, maybe even within the same organization, and understanding what is the reputation of that IP. But the one that really scares me is this third botnet. So this third botnet, when they went back and they looked, this was the controls revealed this third botnet and what was sort of going on underneath, and they realized that this isn't something new. This third botnet had been coming to them for weeks, if not months. They could only tell weeks because that was as far back as their logs went. But this is what we call a low and slow botnet. And this is one of the advancements, the evolutions of the credential abuse botnets that we're seeing more of. So whereas this first botnet is hitting you hard, hitting you strong right now, the low and slow botnet is using all those credentials, using a botnet that may have just as many end nodes, but rather than coming and hitting your systems hard, strong, fast, they're just slowly going and trying a single IP or a few IPs at your site. Those IPs go and move on. They rotate in a few more IPs to, again, try your site. So they may only be used 5 or 10 times per IP, per client against your site. But they're being used consistently across the internet. So they're going and they're attacking you very slowly. They're attacking you very slowly, and they're attacking you very slowly. And they're actually creating as much traffic as this top botnet overall, but they're spreading it out across the internet. They're spreading it out across hundreds of targets. And what's scary about that is this is actually probably long-term the more successful type of strategy of not ever tripping any of those wires that you have that look at the amount of traffic you're receiving, that never tripping any of the thresholds, but actually just going through, hitting a few, moving on, hitting a few, moving on, hitting a few, moving on. I don't have statistics yet about how successful these types of botnets are being, but we're starting to see more of them, of taking and rotating in passwords, rotating in the use of different IPs. And this is one where it really does take a global presence. It's not something that an organization can fight on its own. It's something that it has to be something with a global understanding of the different IPs and how they're being used, a multi-tenant sort of understanding of what that traffic looks like. So that's the one, of all of the things I've seen recently, that's the type of attack that really kind of scares me, because it is something that is being successful. Now, as I mentioned at the beginning, this is one of the other things that concerns me about this. which is who is responsible within the organizations. Let's raise of hands. How many people actually have somebody within their organization who is directly responsible for combating botnet? I see 2 hands. Out of everybody, 2 hands where anybody is responsible for dealing with the credential abuse activity. That's actually not uncommon. In most of the cases when we, again, this is back to a Ponemon report that we did in 2017, 40% of the time, nobody is responsible. In most organizations, nobody has any responsibility for it. Sometimes the CSO or CTO or CIO has direct responsibility, but in a lot of cases, nobody. And we all kind of know what happens to something when nobody's responsible for it. It's not being combated. So what needs to change? First of all, there is that who needs to take responsibility. We need to actually make it the responsibility of somebody. We need to know that within each organization there is somebody outside of the marketing team who's going to be concerned about botnets and credential abuse and what we're seeing. To the cloud, Batman is actually not that far off. We have to actually move a lot of this to the cloud, of actually looking at the data centers model as not being as successful, of the technology looking at that global footprint of botnets and what they're doing. And then we have to encourage more of the botnet takedowns. When we look at what law enforcement is doing, the more that we look at taking down some of the botnets, of actually moving the financial burden to different parts of the infrastructure for attackers, the more successful in combating these types of things are. When we look at the work that, as I said, Europol did for web stressor, that actually had an effect, short term unluckily, but it had an effect on the amount of DDoS that we're seeing in Europe, that the amount of DDoS that was seen globally for a short period of time. Unluckily, a lot of that came back to seeing other types of work being done, which is part of why we see more of the attack traffic moving to credential abuse. And by the way, it's not just us that see the traffic moving to credential abuse, the attack traffic moving to botnets. This is actually something several other organizations have commented on in the recent past. So what I hope you took away from some of this is that organizations, botnets are always evolving. They are going to make changes. It's a cat and mouse game across the board. We're going to see this type of traffic evolved, so we need to evolve to fight it. That background radiation, like I talked about, the one that concerns me is the low and slow botnets that are going out there and trying to stay in the background. Those are the ones that I think are going to be most successful in the long term, and that's a problem for you. That's a problem for everyone. And again, credential abuse is on the rise. So hopefully some of you have read the State of the Internet Security Report, and I'll take questions now. I actually finished a few minutes early.
Visibility of the, if you talked about the low and slow botnets, and if you don't have visibility of the whole internet, you're not Akamai, for example, and you want to detect them, how would you do that? Because, well, I have no idea.
It's whether you're Akamai or another organization, it really does take some tools that are beyond the capabilities of most organizations to do on their own. It's going to take having a view across multiple organizations. That's part of the problem with these low and slow botnets, is that it's only by taking that multi-organizational view you'll ever be able to fight them. And that's their whole plan. That's why they're moving in that direction. And again, why we're moving in that direction. It's only by actually looking at multiple organizations who are being hit by the same IP addresses, same botnets, that you're going to see the traffic. Anybody else? Okay, folks, well, thank you very much, and I'll give you a few minutes back.